Hello and welcome back to Stoichiometry, Vodcast 11B. And 11B, we're going to take our mole concept and our molar mass concept and take a little step further and put them together, right?
Oh, here he comes.
Here he comes again.
Can't start a Stoichiometry podcast without our Technicolor mole.
Moly the Technicolor mole.
Okay.
And his amazing chemistry coat.
We should do that old school musical next year.
We should. Moly the Technicolor mole in his amazing Technicolor chemistry jacket.
Chemistry coat. Okay, this hadn't got started well, Coach Forster.
No, it hadn't.
Okay, flowcharts. Love flowcharts.
Flowchart, this will help you out. It'll save you a lot of time and save you hopefully some...
So do you want to explain this, and then I'll walk us through an example here on the next slide if you want to.
Yeah, so we have our moles are our universal unit of conversion for this unit in chemistry. So everything goes through moles. All right, so you either have atoms or molecules, and you want to end in moles, or you have atoms or molecules and you want to end in mass. Either way, you're going to go through moles to get there. And you can also go from mass. To moles to atoms or molecules. Okay, so if you read the arrows here, if I want to go to atoms to moles, so I want to go this way, I have to divide whatever number I'm given by 6.02 times 10 to the 23rd. Now, I'm going to post a calculator. I have a calculator tutorial I used last year that'll tell you kind of how to use your calculator in order to plug in this exponent here, which is a little tricky sometimes, and we can show you how to do that too.
We can show you in class too, because obviously it's going to be different.
For
all calculators are going to do this a little differently.
Right.
So it is important to know that you're doing it correctly there.
But just know if your answer is given in like 10.1 E22, that's actually your calculator saying 10.1 times 10 to the 22nd.
Right.
So this is calculator language here, the E, and this is human language. Yes. Okay. So if you want to go from atoms to moles, you do that. If you want to go from moles, if you want to go from moles to mass, which is grams, you multiply by the molar mass, which is what we calculated last unit.
So you've got to find that off the periodic table, and that's based on what substance you have.
Right.
Okay.
Right. So it'll tell you that also when you start.
Notice the top half of the flowchart doesn't matter at all what the substance is.
Right.
Okay. Everything's the same. But the bottom half, it matters. Molar mass. It deals what the mass of that substance is from the table.
And if you want to go back, you're doing the opposite. Instead of multiplying to get from moles to grams, you're going to divide, going from grams to moles. And in here, instead of dividing by 6.02, you're going to multiply to go from moles to atoms.
Okay. Let's look at an example, and I'll come back to this chart here once we know. How many moles of carbon are in 26 grams of carbon?
Right. Okay, so we got moles. So we want to end in moles, and we're starting with grams.
In grams.
So let's go back and look and see what we need to do.
So on our flow chart, we're starting down here in grams, Coach Forster. We'll circle that one. Or mass, we're starting at. And we want to go to moles. Okay. And so the instructions tell us we're going to divide by the molar mass. Okay, so I'm going to go back to our slide here.
Okay.
So we know we've got 26 grams. And we want to divide by the molar mass, so I need to look up the molar mass.
Right.
In this case, it's just carbon. It's not a compound, so I just need to look up carbon is 12.01.
And that is our units, our grams per mole. There.
Grams per mole. And so what's going to happen to the units there, Coach Forster?
Well, if you got like units, like the G here, the grams, those are going to cancel out.
So you're just left with moles, which that's what we want, right?
Yep.
And the answer is 2.17 moles.
All right. And of carbon.
Right.
So we got moles of carbon there.
And Coach Forster, I will say, you'll start learning, moles are always going to be kind of a number close to zero here.
Right.
Okay?
They're not going to be a really
maybe
large
a decimal
number.
Or something. If you get a number on moles that are, like I see kids all the time bring me a number for moles of like 10 times 10 to the negative 51st or 10 to the 51st.
Like 10,000, which is bad.
That's... You're probably not plugging into your calculator right. It's probably what's happening there. So you might have us give you a little calculator help if you're getting a huge number for moles. Moles is going to be relatively close to 0, 1, 2, 3, somewhere in there. Okay?
Very good point.
So let's look at the next one.
All right, so how many molecules are in
2.5 moles? 2.5 moles. So let's go back.
Let's go back and look at that.
We're going from moles to molecules.
Moles to molecules.
Okay, so what would we do?
So here we're going from moles to molecules. So we're going to multiply by 6.02 times 10 to the 23rd.
So let's go here. If you'll write that out, I'll go ahead and get my numbers start plugged in.
So 2.50 moles times 6.022 times 10 to the 23rd.
And you get, Coach Forster, 1.51 times 10 to the 24th.
Times 10 to the 24th, and that is molecules.
Molecules.
Okay, so
your atoms or molecules are always going to be a
large
number with a large exponent.
Yes,
like
yeah, because you're dealing with a lot of very, 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 very small particles.
Very small. Mm-hmm. Okay, so let's look. I think we got one more example here. Find the mass.
Now, sometimes you may not say grams, but it'll say mass, which is grams for us. Of 2.1 times 10 to the 24th molecules.
So we've got molecules, and we want to go to mass. So let's see what we need to do here.
All right.
Where are we? We're starting with molecules.
Molecules.
We got to go way down there to mass.
We got to go to moles, and then from moles we got to go to mass.
So we got to do 2 steps.
Then we do.
So we need to divide by 6.02 times 10 to the 23rd, and then multiply by our molar mass.
Okay.
So let's look at this.
Let's see if we can do this.
First of all, we're going to have 2.1 times 10. And you can go ahead and write it out. I'm going to get it all plugged in here.
Okay. 2.1 times 10 to the 24th divided by 6.02 times 10 to the 23rd. And that, of course, is molecules. And then that answer is...
I hit a wrong button, Coach Forster. I'm sorry.
Okay.
3.49 moles.
Right. Yes. So 3.49 moles of NaHCO3, which is sodium bicarbonate.
Okay. Now, what did it say we need to do?
So that's not our answer.
No, that's
no,
just
why
our
did
moles.
I circle that?
Remember, moles is the conversion.
Mm-hmm.
We always go to moles before we can go to anything else, because that's, in chemistry, moles is kind of the base
unit
for going between different things like that.
So we're going to take 3.49 moles and multiply that by the molar mass of sodium bicarbonate.
So we need to find the molar mass there. You ready, Coach Forster?
Yeah.
I'll give you the...
okay, I'll just...
sodium is 22.99. Let's do it.
What do you think? Okay. So 22.99.
0.99. And what's next?
Hydrogen.
1.01.
Plus.
Carbon is 12.01.
Plus.
And oxygen is going to be 16 times 3. 84.01 grams per mole.
All right, so times 84.01 grams per mole. The moles are going to cancel, and I'll be left in grams, which is
293.2.
293.2.
We'll call it
grams. And it's grams of, well, I need to put sodium bicarbonate there. All right, so we usually call this example a two-step equation because it had 2 steps.
So these would be the harder ones.
To 2. Mm-hmm.
Okay.
Yeah.
So you guys are all educated now
on how to do
molar conversions.
Mm-hmm.
So congratulations,
mm-hmm.
and we'll see you next time. It's King Arthur and Coach Forster,
King of Chem,
King of Chem, signing off.
Signing off.